Hey everyone, in this video I'm going to go ahead and walk through, this is question 10, I just realized I didn't put that there, question 10, from our chapters 10 and 11 worksheet. And this is just a regular hypothesis test like we've been working through. So in this question we have Chicken Delight claims that 90% of its orders are delivered within 10 minutes of the time the order is placed. A sample of 100 orders revealed that 82 were delivered within the promised time. At the 0.1 significance level, can we conclude that less than 90% of the orders are delivered in less than 10 minutes? Now if we take a look at this problem, you'll discover it's a little different than some of the others we've covered. It doesn't have a mean or a standard deviation mentioned in here. What we see is that we have percents happening, or fractions, right? We have a sample of 100 orders revealed that 82 were delivered from the promised time. Because we have fractions and percents, we are dealing with a proportion type problem. So we have to think just a little bit differently about that. So we have some variables we need to put down. So Chicken Delight claims that 90% of its orders are delivered within 10 minutes. So 90% is what we're focusing on. And that 90% is what we believe to be true. So that's our population variable. So in this case, it's our population proportion, which is notated by pi, whether the symbol or I'm just going to write pi like that. So pi is 0.90. It is 90%. We then have a sample of 100 orders and 82 of them were delivered at the promised time. I'm going to jump down here for just a second. So we've got n is 100, and up above here I'm going to put what we use as x. So x is the number of successes. In this case, a success is delivered within the promised time, and so there were 82 of them. From this, we can then solve for p, which is the sample proportion, which is just 82 divided by 100, which of course is 82%. Okay, so we get 0.82 as p. We then have our significance level, so we have alpha is 0.1. And then we have our question, which I'm going to go ahead and underline. Can we conclude that less than 90% of the orders are delivered in less than 10 minutes? I'm going to switch over here to black if I can find it. Okay, so now we can write our hypothesis statements. So we have our null and our alternate. And the variable we care about is that percent, our percent, which is the same as proportion. So we have pi, and the question was, is the proportion or the percent less than 90%? Okay, so less than 90%, and then we have greater than or equal to 90% sitting in the null. Okay, so now we have that. So we have our null and alternate hypothesis statements, we have our variables, and now we're going to go ahead and draw our curve and figure out what our critical value is. Let me come over here. So here's our normal curve. Now first of all, you have to decide what distribution are we using. Are we using Z's or are we using T's? This is a proportion problem, and proportions are always the Z distribution, no matter what. Proportions are always the Z distribution. Okay, so we have the Z distribution. And we have a less than symbol in the alternative statement. Therefore, we have a one-tailed test because we have inequalities, and we're going to be on the left side because we're talking about the less than 90%. Okay? So now we need to figure out what is our critical value and then what is our test statistic. So I have my critical Z. We're going to go ahead and figure out. Use my f of x, and we did this, at least I did this earlier, so we got norm.s.inv. I'm going to put in a probability, and it is going to give me a z-score. Okay. And the probability we have is our alpha, which over here is our 0.1. Put 0.1 in there, and I get negative 1.28, as my critical value. So when I solve for my test statistic, if I get a value less than negative 1.28 in the shaded region, then I will reject the null. Okay, So now we're going to do our test z, and the formula for this one is z equals p, because that's our sample proportion, minus pi. Notice that this is very similar to when we were using the means. The sample one always comes before the population one. So sample proportion minus population proportion over the square root of pi times 1 minus pi over n. Okay, so this one's a little bit more complicated to put in Excel, and if you need to break it up, you can. You could do one cell be the numerator, one cell be the denominator, then do the division later, whatever works for you. Okay, so I have my numerator is p minus pi, okay, that's the easy part, divided by the square root, okay. Now, think of this as we're starting over again. So I've got my parenthesis, but now I'm going to do my numerator. So I'm going to do a new parenthesis because I want to make my numerator in its own set. So I'm going to have, once again, let's see, what do I have? I have pi times, another set of parentheses, 1 minus pi. I'm going to close that, and I'm going to close off my numerator. Notice I still have 1 after the square root that's not closed off yet. And then I'm going to divide that by n, and then I close off that parenthesis, which closes off the square root part. Okay, so it's a little bit complicated, but you can do it. Just take a little practice. And once again, if you need to break it down a little bit, do that. Whatever works for you. Okay, so then I end up with a negative 2.67. Let me get a new color. So negative 2.67 is going to be in the shaded region, right? It's less than negative 1.28. Therefore, because it's in the shaded region, we would reject the null. That's our decision. And our interpreting the result would be re-answering this question, saying that we can conclude that less than 90% of the orders are delivered in less than 10 minutes. Hopefully that helps clarify a little bit about proportions, and I'll see you in class.